topic for today is a couple of measurement devices. There are basically two devices that are used to measure stuff in circuits. Ammeter is the first one, and you might notice that am looks kind of like amp. This measures current. In order to measure the current, you need to be hooked up to the circuit. So if you think about it, let's say we've got a battery, and we've got a circuit that's doing whatever it's doing. Okay, and we want to measure the current, say, through this resistor over here. An ammeter, it measures the current, right? And in order to measure the current has to flow through the ammeter. And if we want to know the current going through this resistor, then that means we want to hook the ammeter up in series with that resistor. With the circuit element, we hook it up in series with the circuit element we want to know the current through. Alright, so the ammeter would have to be hooked up, say, for example, we could put it after the resistor, before the resistor. I have more space over here, so I'm going to put it after the resistor. We could attach it over here, so that instead of, and I'm, get rid of that wire. We hook it up in series with this resistor, so that the current flows through the resistor, then it flows through the ammeter, and the ammeter can measure that current because it is in series with the resistor. Ideally, ammeters would have zero resistance, because if they have resistance, they're going to change how the current would flow through this resistor, which is, we're trying to measure the current through that resistor. So we don't want our measurement device to mess up what's happening in the circuit. Practically speaking, all that really matters is that the resistance of the ammeter is a lot less than the resistors in the circuit. So if you've got an ammeter and the resistance in the ammeter is like it's like a 10 to the minus fourth ohms, and the resistors are on the order of like 10 or 12 ohms, then you're doing all right. So ammeters need to be hooked up in series with the things you want to measure. A voltmeter, I forgot the T there for a second. A voltmeter, as you might guess, since it has the word volt in it, it measures a potential difference. All right, and because it measures a potential difference, it should be hooked up in parallel with, what you want to measure the voltage across. Okay, because we talked about this when we were dealing with resistors and capacitors in series. The voltage drop across this resistor is the same as the voltage drop across this resistor, right? So if we've got a circuit, and I'll make it the same circuit as up top, and I want to measure the voltage drop across this resistor, I need to know the potential here and the potential here, and so I hook up my voltmeter in parallel to that resistor. Sorry, I drew a lot of lines there. But if I hook up this voltmeter in parallel to that resistor, now I can measure the potential at each of these 2 points, get the potential difference across the resistor. So that's how you deal with measuring stuff in circuits without, and you don't want to change the current flowing or the potential difference by adding this voltage. So ideally, the resistance of a voltmeter is infinite, because if a different amount of current flows through this resistor, then it'll have a different voltage drop across it. And if there's infinite resistance through this voltmeter, then no current could flow through it. And just like with the ammeter, though, of course, you can't have infinite resistance. Practically, as long as the resistance of the voltmeter is much, much greater than the resistance in the circuit, then you're good to go. So voltmeters are typically made with high resistance, and ammeters are typically made with low resistance. There is a handy device that's, well, I guess it doesn't have to be digital, but I've always used digital multimeters, so I thought of it. A multimeter has an kind of an adjustable resistor inside it, so you can switch off between what you want to measure. A multimeter can measure current, it can measure voltage, sometimes it can measure one or two other things, but the point is that there's this switch that you flip on the multimeter, so that, and what that does is, number one, it changes what the display is showing you, and so it changes what what you're getting on the screen. But in order to do that, it adjusts the resistance In order to do that, it adjusts the resistance so that if it's measuring current, it's going to make its resistance very small, and if it measures a potential difference, it's going to make that resistance very large.